Привет, ребята. So I just forgot to connect clicker. So yes, so my plan for today is to get you excited with Room, and hopefully in 40 minutes you will see that Room is awesome, but there are better libraries actually. But then Room is nice as well. And I always skip part about me, but this time I will have a slide about me, and there's a good reason for that. So I gave a presentation, I think a year or maybe 2 years ago, about Binder. So this important component in Android that is being used by Android to communicate between activities and services and whatnot. In that presentation about Binder, I talked about Diane Hagborn. By the way, that's awesome surname for a hacker. So Diane Hagborn, she's a part of Android core team. She basically worked before Android on Binder for BIOS, and then she joined Android and basically created the important bits of Android. And she created a blog post. In that blog post, she tried to answer the question what kind of architecture we should use on Android, MVP, MVC, and also maybe MVVM. And basically the gist of her article is that Google, they don't care what architecture do we use. They just provide us with a bare platform, so to speak, and activities, services, and whatnot. And then we should somehow construct our applications using our imagination. And of course, if there is a gap, people will step forward and try to fill in this gap. So some people decided to just ignore Android and go with cross-platform solutions, and others decided that the reactive programming is a solution for everything, and that's the way to go. There were others who thought that the proper clean architecture is the best approach, and some others, whatever we do, just said whatever we do is going to be fine as long as we don't use fragments. And others decided that tests, that's an important and crucial thing, hopefully in Kotlin. And more people decided that business side is even more important than a technical side. And then, of course, there's Florina. And Florina decided to answer this question looking at MVP, MVC, and MVVM. And that was, like, I would say, before this Google I/O. So Google just bare Android and people coming up with ideas how to program Android, how to structure applications. But this year, Google decided to introduce architectural components and suggest us, developers, that maybe we could use them and use them to build our application. And today I'm going to talk about Room. So this is one of those components, and Room is persistence for Android. So let's talk about setup, how we add Room to our application. It's super easy, but before that, let's imagine an application. My application is going to be a to-do list. Okay, so I have a project with few properties like name, ID, and the creation date. And my project will have tasks. Okay, so task is another entity in my application, and task is going to have like some more properties like ID and name. And that's not important, but basically I have an application with a project, that's the orange thing, and a blue thing, that's a task, okay? So that's the idea of my application. Now I will try to use Room to implement this application, and also I will try to use requery, another very cool library, and compare Room to requery, okay? And of course I need and I want to have this relation between project and a task, and vice versa. If I get a task, I would love to see what project this task belongs to, okay? So how to add Room to our application? A few lines in Gradle file, and we are done. It's kind of obvious that we, sorry, I started. So to add a requery to our application, a few lines, and we're done. Same stuff with Room. We add a few lines, and we basically can add a persistence to our application. So in that regard, I would imagine that Room could be much easier because it's a part of Android, but still it's just a few dependencies in a Gradle file. And the only, I would say, interesting thing is that this test implementation line, so we can test our migrations. We can skip this part and just focus on using Room and ignore testing migration. But if we want, we can add this extra artifact. Okay, so same stuff for Room and require a few lines in the build Gradle, and we are done. Then to use a database in our application, we need to create this parent object that will give us access to tables and entities that are stored in database. And for Room, we need just create an abstract class that extends Room database. A few annotations are required. Here we have database annotation that basically states that what entities my application consists of. In this case, this is a task and a project. Then also, if I want to make a conversion is It's funny thing because in SQLite you can keep in database only a few types, mostly strings and integers. And we have, if we have a more complex object like a list of strings, we cannot keep that in database. So we need to, somehow to convert that to a string. So there's this conversion idea. So basically, it's as easy as to take a list of objects and convert that, maybe using JSON to a string, and then store the string into database. And then when we need to get this data from database, we just do the opposite, so convert string into a JSON. So with Room to create a database, I just created this abstract class, extend Room database, add a few annotations, and the rest is basically a boilerplate code. Maybe the only interesting part here is at the bottom, those two extra lines. I will explain them later, but other than that, it's basically a boilerplate code, okay? With require, it's not much harder. So basically, another class that will be our access, give us access to database. As you maybe notice, there are no annotation at the top because actually require is looking at your all files and gathering all the information from your files. So you don't need to specify this at this point, but the rest is very similar. I just create a entity store, and if I want to access database, I just access it through this entity store. So in that regard, I would say it's a bit easier with require, but not that hard with Room. Then having this method object to access database, I can access entities in database, but first, of course, I need to declare those entities. So how do we declare entity using Room? So basically, entity is just a class. In this case, I will just use Java, but obviously it also works or should work with Kotlin. So I just create a class, add a few fields to this class. In this case, I have ID, task, and creation date. Date, of course, it's a Java unit date, so it's not something I can keep in database, so I will need a converter for that. And I will just assume that I have this converter, a converter that's taking a data object and changing that into integers. Super easy, to be honest. But for now, let's assume we have this converter. I will not focus on that. So we have this date. I want also this task to be to belong to a project, so I need a project field and a status field. There's a small problem here that and of course project is a separate entity, okay? A separate entity with some new fields. There's a small problem here, status as simple enum, okay? Small problem here is that we don't have relation in Room. So I cannot keep in database something that is a project. I would have to serialize project into a string, or sadly just keep an ID of a project, let's say as a string, because Room doesn't support relations. I will talk about that later, but for now, sadly we cannot do that. So I have to put a string with ID to another entity, another table. Of course, to mark this for Room as entity, I need this extra annotation at the top. And this annotation can take some parameters. Some of them just are super obvious, like changing name of the table. Some are more complicated, like these foreign keys. So I said that there are no relations with in Room, because they are none. But I can use foreign keys. For instance, when I add this foreign key, like here, then when I will try to delete a project, I will also delete all the tasks that belong to a project. So there will be some sort of relation, but only in this case that will be just active, like when I will be deleting projects. So this is like a kind of relation, but not true relation. Okay, so that would be then a full Room entity. Of course, I would just maybe add a primary key. And regarding primary key will be an integer and string. If it's a string, I cannot ask Room to generate the value for me. I have to just put this value by myself. If I use ints as IDs, I can ask Room to generate IDs for me using this extra parameter to annotation. Kind of cool, to be honest, but I always stick with strings, like unique IDs. So in my case, to have this ID generated for me, I would just create a constructor. And in this constructor, I would just set value for ID. So that's a way of auto-generating ID, okay? If I want to have another constructor, because I want also set a name of a task, I would add another constructor, but sadly Room would get confused. So I need to mark this extra constructor as ignored one, so that Room will just use the default one without parameters and not be confused that there are two constructors and Room doesn't know which one to use. Okay, I can also ignore fields if I want, but yeah. So in the end, the full entity for Room looks like this. entity at the top with some parameters, primary key for one of the fields, a few constructors, one is ignored, one should be not ignored, the rest have to be ignored. And that's the, skipping of course getter setters, they are important, but in the end, this is a entity for room. And with requery, I must say it's much funnier to create entities. So let's compare room to requery. Similar entity in room would look like this. I get an abstract class. Instead of primary key, I just go with key. As you can see, I can have relation in here, many to one to one, many to many. That's super cool. And a way to create, to auto-generate a value for ID, which is not integer, I can just create a special method pre-insert that's gonna be called before the object is gonna be added to a database. So it looks kind of nice, I would say. And for that abstract class, requery, we create a concrete class called, in this case, task. Okay, so I will use in my application also, just like in this case, I will just use task, because requery gonna create for me this class called task, okay? If I want or I need, I can add converter at this point. So that's also kind of nice that converters are, let's say, attached to a field, not somewhere in the completely different file, but to each field I can just attach a converter. Funny fact, I don't have to do that for date or for enums because requery supports that out of the box. That's not true in case of room. And like I said, I don't need that. So eventually, I can also add some extra logic after loading data from database with these extra annotations, and I believe there are more for updates and whatnot. So lots of features are available in case of requery, much more than in case of room. I would even add that you can use interfaces if you prefer that from abstract classes. So basically with room, you can use everything. If you are a guy who likes to use auto-value, you can use that as well. And even if maybe it's not so clear, but you can extend observable, that's one from data binding, and room, requery, we create necessary methods for you so that this object can be used in data binding. And of course, as you can see, there's a persistable here as well. So room will add all this boilerplate for us so that we can pass object between activities. So super useful. So to keep it short, with room, there's only one way to create entity and a few annotations, and in the end we use this entity in our application. With requery, there are many different ways to create entities. A bit more annotations, not sure if that's good, but that can be useful. And we just declare abstract class or we declare interface, but later we get from requery a concrete class that we use in our application. So that was how we create entities. Now let's look at how we make queries. So let's imagine that we have our entities here on the left, and we have our application, and we somehow want to send data between database and our application. And we use DAO for that. This is what Google suggests, and I implemented DAO also with requery. Some people say that you need a repository and data store and more abstraction layers. With room, we have just one abstraction layer. It's called DAO, and I just recreated the same abstraction layer for requery to compare both. Okay, so we just have this DAO between database and our application. So how do we make queries? First of all, I will just focus on Eric's reactive programming. Okay, you can do regular queries, but they are not that interesting. I'll just focus on making reactive queries. And with room, you can make a query like that. So get all the tasks or get all the tasks as a flowable. Okay, so two ways of doing a list or a flowable. And eventually, they have support for live data, which is, I guess, their version of Eric's. But that's what's supported by room. With requery, I can just get a list of elements. I can get a single, it's just one element. I can get observable, that's something from Eric's Java 1. And actually, I can get everything I want because room is supporting Java 8 and some strange things I never heard of, but it's all supported by requery, so it's super cool, to be honest. And confusing as well. But when it comes to inserting data, with room, there's only one way to insert data. So there is no a reactive way of inserting data. You have to program this. We have to program this ourselves. In case of requery, we can insert data also having this reactive interface, which is kind of useful when the whole app is reactive. Then insert is also can be added to a stream. So let's create a DAO for room and then requery. So with room, to create a DAO, I create interface, add some methods. So basically, let's imagine I want to get data from database, like one task or a list of tasks for a project, and then insert task. And then if you are listening to me, you cannot have singles, you have to go with flowables. That's a pity. And then, of course, there is no singles, so it has to be a void. So with room to create an interface to get data from a database, we go with just like two calls that will get us flowables, a stream of data, and one call to insert data, okay? And we mark this with annotation DAO so that room knows that that's an interface for room to process. And out of that, room will create a concrete class for us, and this concrete class will just basically make these queries and do all the logic and like parsing data from database and whatnot. So we just declare interface in the world of room, okay? And the one last bit that is a bit confusing to me, that is actually we have to write the queries ourselves, which is kind of strange because we don't have to do that with GreenDAO and requery. Maybe it's kind of useful, but it's kind of strange. So it's not like we have this REM, we don't care about SQL. We still need to write a query. So in this case, we need those annotations here as well, okay? So now we have full interface, and we can ask room to create for us a concrete class that will make those queries, okay? How it looks when it's generated, basically we'll get this class, in this case is task_DAO_implementation, and inside this class we have implementation of our methods from the interface. And if you look inside those methods, there's lots of boilerplate code. This only part of one of those methods, parsing data from SQL, taking cursor and doing all this boilerplate code for us. So it's all from generated by room. So how it looks with requery. So sadly, we have to write the whole code ourselves. So with requery, there is no easy way to create DAO. We don't create an interface or abstract class. Sadly, we have to write the code ourselves. But what's cool, as you can see, the API, it's fluent and super nice. So to make a query like here, to get a task from database by task ID and return a flowable, so a stream, is as easy as just to get this from data, select a class where ID, and then get this and convert that to flowable. Super easy API. So we have to write this, but it's not as scary as this lots of Java code in this case. We just have to write a few lines. So it's kinda cool. And what's cool also is that basically we can use all the power of reactive programming here. So if I want to have a list, I just convert flowable to a list. And actually I don't have other example, but I show we can use first or error and other things, so we can return a single very easily and whatever we want. So with requery, some code is needed, but it's super easy to write this code, and it's kind of nice API. Speaking of Kotlin, someone asked me this question. So yes, there is a support in room for Kotlin, but sadly, at some point in time, it wasn't working with some technical problems with Kotlin annotation processor. So I will say maybe it works right now, maybe not. For sure, there is no specific API for Kotlin. If it comes through, it should just work. With requery, if we have such a query like here, so I just basically get person from database with name Bob. A part of requery is this Kotlin API, and they have this nice DSL prepared for us. We can make queries like this, and it's super cool. So requery has a support for Kotlin, and it works with Kotlin. Room will have eventually, and has at some point in time. And that's that. Now let's talk about making queries themselves and having fun with streams. That is super confusing, and I think it's the most interesting part about Room. So Room is supporting, both Room and requery, they are supporting reactive programming, both return flowables, but sadly those streams behave completely in a different way. So it's super confusing. So let's imagine that I want to query a database and get a non-existent record from or entity from database. So in this case, first of all, I should just remind you that this just returns a flowable by ID a flowable of projects. Okay, so when this called get projects should return a stream of projects, and with Room, as you can see here, when I make this call, this stream doesn't complete. Why is that? Because Room is listening to the database changes, and eventually, if someone inserts data into database, I will get this inserted data, okay? So with Room, all the streams are like never ending, because Room is constantly observing tables for us, which is, I would say, kind of nice. But what's going to happen when we query for non-existent object? as you can see, we don't complete, we don't get any value, we just basically hang forever waiting for new data to arrive in database, which is, I would say, kind of confusing. So it's not easy to use room when you query for non-existent data. So the only solution I found is basically to add a timeout, which is kind of not nice. When I add, in this case, 4-second timeout, and of course I make query, it never completes, but then when time passes, actually I will get timeout exception. So it's not like no such element exception, it's timeout exception, but that's the only way to stop room listening for database changes. I believe that they're gonna change that in next version of room, introduce maybe single, so that room will support a single API, but in this case, it's super annoying to query database for non-existent elements. I tried first on error, but first on error only works when the stream completes. And in this case, the stream never completes. So we cannot error out because there was no data in the stream. With requery, when I use flowable and query database for non-existent object, I will just get complete. So maybe it's not that useful because the stream will just complete and not get me any data, but I don't have to add timeout. And how to do that nicely with requery, I will show you in a second, but first let's compare two things. So with room, flowables never complete because room is monitoring database for us. With requery, it's the opposite. Streams complete and database is not being monitored. It's completely opposite scenario, super confusing. But of course, room supports both scenarios, and requery. And with requery, I can also have the same approach like with room. So I can get data from database and eventually also observe a table for changes. And how hard is to do that with requery? So that's a query when I just get data, a stream of data from database, but I'm not observing table. So if there was no data in database, the stream will complete, I will get no error, I will just get no data, that's that. I can ask requery to observe the table for me, like here, use just this extra line here, observable result, and now this stream doesn't complete, and if something new arrives in table, I will get those new elements in that stream. And how to get an error when querying database for an element? As easy as that. I will just ask requery to get me first element or error. So with requery, I can use power of RX or this extra call here to have whatever I want. A stream of data that completes, a stream of data that never completes, and a stream of data that will error out if there is no element in database and returns single. So it's kind of convenient in that regard. Sadly, that's not available yet with room. That was that. That with requery we have everything we really want, and with room we have only one scenario supported right now. And I can imagine that they will just introduce more capabilities to room over time. Okay. Let's talk about relations because it's also super interesting. And like I said, sadly, we don't have relations in a room, so that's why I will focus on requery right now, okay? So we have this object, and this object, so this is a task, and task has a project inside with this extra annotation that basically makes this, creates a relation for us, okay? And then when I query database, I can just pass the whole object. Obviously, this object has an ID somewhere inside as a field ID. And the requery, we just know that when I ask to select a task and I provide whole object, like a project in this case, it gets ID from this project and make a necessary query for me. For a developer, the API is super nice. We just have a project here as a field. We make this query like regular one. We don't have to get ID here. And eventually, everything just works. All the necessary tables are created by query under the hood. We don't have to care about that. We don't have to join tables wherever. It just works. There's a small caveat here. If the relation is one deep, like in this case, so I have task and there is a project inside. So when I query for task for a particular project, like here, a requery will get me a task and also all the fields from the project. Okay, that's kind of nice. But if there is another object inside of a project, let's say an owner, which is another entity, and then owner has another entity, let's say company. So requery only will go one level deep. So we get me a task and a project, but all the fields from the user and all the fields from the company are going to be empty. So that's a not so convenient, but to get all the data, all the levels deep, we need to write some crazy code and ask a require to fill all the necessary fields. So maybe it's a cumbersome, but if someone needs all the objects, all the level deep, it can be done. Just require has relations, and require database gets one level deep. That's that. And by the way, that's the reason why there are no relations in Room. The reason that sometimes it's not obvious how many levels deep the database will get data for you, so they decided don't implement that at all, okay? So how it looks with Room, we don't have relations, but we have a nice thing called embedded, so a nice annotation which is called embedded, and this annotation we can use it to have some sort of relation. So let's say we have our task, and let's imagine we want to add a color task, like important task should be red. So a color will be a name and RGB values. Okay, so I create another class. It doesn't need annotation entity at the top. Okay, I just create a class, and then to my original class that is annotated as entity. I just forgot that here on the slide. I just add the extra line and add embedded annotation. What's going to happen is that Room will create a table for a task with all those columns in here, and also all the columns from the color, so all those columns from here. So there will be no two tables. There will be no database at the relation at the database level. But for me as a programmer, I will have like some sort of relation at the API level, because when I get a task, I will also have an object color, not like bunch of extra fields. Okay, so it's let's say some sort of relation. It's not like proper table-based relation, I would say. Okay, and the query in this case is also kind of nice. So this is Room DAO. I just create a method that will return a stream of colors. I query database for task by ID. So here I query task table, but here I get color object. Why? Because I just ask for those 4 fields, and those 4 fields are part of this class. And there is this embedded annotation here. Some Room will figure it out and query task table, but don't want to return the whole task object, only a part of this object, in this case color. So it's some sort of relation, I would say, but it's not full-blown relation. And it's also super useful, for instance, if all those values, let's say imagine that I only care about task and creation date. I can create a POJO object called task and creation date with few fields, and then ask require to get those 2 fields, return this object, and require, instead of getting the whole object basically empty with only those 2 fields filled in, you get me separate object with all the 2 fields of that object filled in. So this mechanism here is a way of having relations, and also a way of querying table for not all the columns. It's kind of useful, and I was kind of impressed that this is a part of Room. And honestly speaking, I wasn't sure if there is a support for that in requery, but obviously there is a support for that in requery. Anyway, with this extra annotation, so this, let's say, relation-alike annotation, we can also make queries like this, so more complicated. So this is a like proper SQL query, lots of joins and lots of crazy stuff happening here. It's gonna use 2 different tables, or maybe 2, loan and user. So it's gonna query multiple tables and return a book. So it's a way of connecting multiple tables. But of course, it's not a proper relation, okay? But that's supported by Room as well. And if it comes to requery, so let's sum this up, and there are no like full-blown relations in requery. We can use embedded or those complicated queries, joint queries to simulate that. And with requery, we have full-blown relations, many-to-many, one-to-one, and many-to-one. And of course, we have support for embedded as well. And I checked dates, so they added this support a long time ago. Don't want to say that the Room is copying features from requery, but obviously in this case, they copied that. Okay, so regarding relations, so there is, according to Google, and I must agree, there's a good reason why there are no relations, and that's the reason here. If you want, you can follow the link. I will post my presentation. But between those lines, basically, it's being said that we developers, we are not care enough, and it's better not to provide us with relations, so that we don't make queries and then get data and forget that not all the data was fetched from the database, and then we use this data in the main thread to show in UI, and basically then we make queries in the UI thread to get the missing data from database. So instead of giving us a chance to use that, and they decided to not have this feature. And this is explanation in here, right? Okay. Require supports that. So let's talk about testing, because testing is important. And I must say that I was always mocking database interface, because it was kind of hard to set this up in tests. And with both require and Room, I would say it's super easy and even fast. Okay, so how do we test using both Room and require? Let's start with Room. We need a real device to run those tests. Obviously, we actually could use this on our computer, like on Mac or ThinkPad, but the SQL library is going to be different than one on a real device. That's why it's highly suggested to run those tests on a real device, so that we use this old version of SQLite that is on Android devices. Okay, so it has to be run by Android JUnit Runner 4. We need, of course, to create our database. What's cool with Room is that they support this in-memory database, which is super fast. And we don't have to delete the database after each test, because it's in memory, okay? So basically 2 lines, and then we can write our tests. Of course not, because if we use flowables, so reactive programming, we need to change the scheduler, so database won't be executed on database scheduler. And I found that the way that worked for me is basically use this API here and provide my own task executor. And obviously that's not the way to go, because then I found article from Florina, and Florina suggested using this extra rule. So if I use this extra rule, then Room is going to use this instant task executor, so I don't have to wait for the scheduler to execute my queries. So that's that. We just create database. Don't forget to do that. Use in-memory database. Then we just add this one extra rule to use instant task executor. And we're almost done. Of course, in case of Room, we have to get all those DAOs for us from database. And then we're really done. And we can start writing tests. And this is one of the tests I created for this presentation. And I was here playing with querying database for a non-existent value. As you can see, it's really a stream that's never complete, and eventually when I insert new data, I will get this new data from database. So that's a test I wrote for this presentation using the setup. So just basically a few lines in setup method, and then you can just basically have the whole database in your tests. You don't have to mock that. What's interesting here is that we use those DAOs, and those DAOs basically have some methods. That's all interface, so we can mock that with Mockito. So if you don't want to use like a real database that will require JUnit Runner, you can easily just run it on your computer without Android device. You just have to mock all those interfaces. But honestly speaking, I very much prefer this API and real database, real inserts, real queries. It's not that hard, okay? So with query, I think I skipped it. So with, sorry, I'm afraid I skipped this slide. So with query, the setup is a bit different, not that hard. The only difference is that actually you have to delete database after each unit test, because I couldn't find an in-memory database. But finally, it's not slower than running this. Those tests are not slower than the tests using Room database. Okay, so summing this all up, my thinking about Room, comparing it to requery, is as follows: if you were using like raw SQL queries, content values, this old stuff, like low-level Android API for database, then definitely Room is good for you, because it's step forward. It helps a lot. It has really nice API. You can very easily test those things. It's definitely a step forward. But if you were using GreenDAO, or like in my case, requery, it's definitely not for you, because it's missing lots of features. Some things are acting completely different, so it wouldn't be a drop-in replacement. For instance, because of those the difference between streams, right? So most probably, if you have this full-blown clean architecture, you could change data store and help yourself at the repository level, for instance. But if you don't have this full-blown architecture, you would have a hard time changing all the queries and reactive streams to make sure that you will add timeouts to timeout queries for non-existent data. That's going to be painful. So at this moment, definitely, if you have requery or green DAO, don't switch to Room. If you want to play with Room, but at this level, it's missing some features. And of course, I don't know what's going to happen, but looking at the features that Room has, I can imagine a couple of more features that should be copied from other projects to Room, and hopefully that's going to happen. So I would say a single interface, not only flowable, that would be cool, and that's the most important, I think, at this moment. That would help with those never-ending queries. But then there's Florina, and I would say that's the biggest asset of Room. Of course, there's a Google behind that, but Florina, I would say, this is the most important thing. The reason for that is she's an awesome speaker. Now she's promoting Room. So to see like Florina, not talking about Room, but about architecture, just check this link. The best presentation you can imagine about MVP, MVC, and MVVM. And I would say that's the power of Florina. And then also she wrote a few blog posts about Room. So here are links to those blog posts. She's talking about data migration. That's why I skipped that in my presentation, because it's everything in her presentation. She touches reactive programming. She even has a blog post on an example project, how to convert application, like old application to Room, step after step, what you have to do to convert old code to Room and don't lose any data. So not only blog post, but also there is a whole repo with I think 4 different projects using different approaches, reactive programming and whatnot. So having in mind that she's going to promote this technology, I can imagine that we'll be going to be even well known, for instance, than requery, which is super cool. But most of people that doesn't use requery. Who's using requery? Yeah, that's what I thought. So that's that. If there are any questions, I'm happy to take them.
Hi, great talks. Thank you for great talks. I want to ask about performance between these two solutions, and the second question is supporting of lazy loading of data in lists.
Okay, so if it comes to the performance, so it works for me. I mean, requery works for me in application. Never noticed that something it's slow. The only problem I had with requery, it was too many connections to database. So I would say it wasn't requery, but more SQLite. So I'm not sure which one is faster. I wouldn't say that, let's say, requery is slower. It just works. And so I never focus even on a speed. I'm always focusing on API and ease of use. So and with requery, it's super easy. I guess also with Room, it's super easy to use and test. So that were, like, let's say, more important factors for me than speed. So it's hard for me to comment on that. And if it comes to lazy loading data, so with requery, when you query data when you query a database for entity, you get all the fields from the entity and one level deep all the relations. So like in my example, I have a task with a project. So if I would query database for a task, I would get all the fields in the task object. I would get all the fields of the task object and also all the fields of the project entity, okay? But it's only going one level deep. And if you have like a nested relation, like task has a project has an owner has a company, and you query for a task, you need to ask Room to get all the remaining after project. So you get task and project, but you have to ask Room, get me also owner and get me also company.
No, I asked about if I have list of projects and yes, if I have list of project about 1,000 of values, and I do not need all values.
Okay. So sorry. So for both Room and requery, you can also use cursor and get data as a cursor, and then you can iterate over cursor yourself. So when you get a stream, a flowable, I can imagine that under the hood there's a cursor, and when you are getting data from a flowable, and this is how flowable basically reactive programming works, this flowable is going to ask database for more data, okay? That I can imagine that this is how it is implemented under the hood in case of require and also in case of a room, that they are using cursor API, so you are not getting all the results, like millions of results from database at once. Both libraries will query database using cursor API to get more data. But if you want to do this yourself and you don't trust them, you can use get cursors for all the queries and lazy load data yourself. Take first 100 rows, and then when you process them, take another 100. Not sure if that was your question. If not, let's take it offline and I'll try to explain it better, okay?
Okay, so if there are no any other questions, so we can finish. Thank you, Alex,
Thank
for
you
the
very much.
presentation.